Hey guys, it's Galactic and welcome to another episode of the C# 2D Game Engine series. So in this episode, we're going to be dealing with the complicated problem of sprites rendering and sprites loading. So I don't think this video is going to cover both topics today. I think I'm going to split it up into two parts. Today we'll work on the sprite rendering portion. Obviously we won't be able to actually render a sprite because we're not going to be loading it in yet, but once we do that, next video we're going to do the loading logic, and then it'll all come together and it'll work perfectly. So without further ado, let's get right into it. So how does a person load in a sprite? Or no, more importantly, how do you render a sprite? Well, it's actually not that difficult. Okay, the way OpenGL does it is similar to how we have our vertex positions. Every vertex essentially has a texture coordinate, or more commonly referred to as a UV coordinate. Now, the UV coordinate or texture coordinate, as I'm going to refer to, is essentially telling OpenGL how you want to map a texture to it. And then it's just a matter of loading in the texture, binding the texture to a texture buffer, and then enabling that. Boom. It's that simple. And then obviously you have to free it. But, you know, that stuff isn't too important. But so, if it's that simple, then why are you splitting up into two parts? You may be wondering. Well, the reason I'm splitting up into two parts is because it's a lot of work we have to lay down. Not necessarily for the rendering portion, although it's not necessarily the easiest thing. It's more for the loading, where we're actually going to have to do a little bit of architecture, believe it or not. Anyways, let's get right into it. So, let's go into our vertex. Obviously, I'm already in it, and I'm just going to remove these. There you go. So, over here, I'm going to make a public vector2, another vector2, texture coordinates. Okay, that's good. And then obviously in our constructor, we need to require texture coordinates. We're going to say it is not a vertex unless it has texture coordinates. In fact, why don't we just go and make these private? Yeah, so with C#, you can just go get. So you cannot modify this once it's been created. That's what essentially I'm trying to say. And over here, we're going to say float UVX, UVY. Now, the reason I'm not going to call it texture coordinate X, texture coordinate Y, is just because it's too much to write, and I'd rather prefer not to. And we still have to go back to the constructor and finish it. So there you go. Or no, we don't want to create it. We want to set it. There you go. There else we have our constructor. In fact, I'm going to move this up just because. So, the next thing we want to do is somehow get our data. Now, that's a problem at the moment. We're not able to get our data. So you may be wondering, what do you mean by get our data, Glum? Well, what I'm trying to say is, we need to, you see how we're having a process method? Well, we need to be able to get a float array of this data in floats. Well, this is not too difficult. The first thing I'm going to do is just rename this to get data. Obviously. Okay, so now that we've gotten our, this does the processing for getting our data, but it's not complete. It only includes our positions. So what we want to do is, this is quite simple. Let's just walk through the code first. So here we have a count, okay, and we have a float array data is equal to new vertices.length times size. And in fact, we don't even need this size anymore. Okay, we're gonna get rid of the size. And for now, I'll just leave it in here, but we'll change it in a minute. So now so right now size pretend is 2. Okay? Then we do for each vertex in vertices, data count is equal to vertex.position.x, data count plus 1 is equal to vertex.position.y. And you see how that works? And then we increment count by 2. So that's all we have to do. Now, we just have to do the same thing for the texture coordinates. So instead of making this 2 now, we're going to have 4 components. our position.x, position.y, then our texture coordinate.x and texture coordinate.y. So then data count plus 2 is equal to vertex.texture coordinate. We have to rename that. Texture coordinate. And then I'm just going to copy this, make that 3, and make this y. So now we're not incrementing by 2, we're incrementing by 4. We're incrementing by the amount of elements per vertex. Okay? In fact, I'll comment this, just incrementing by the amount of elements per vertex. So that's all we really need here. Now it's just a matter of, okay, so now we have some errors in here. But yeah, it's just a matter of fixing our mesh 2D class. Okay? So we have our VBO, IBO, and size. Now that's all perfect. In fact, nothing is going to change in this code right here. This code is going to stay the same. In fact, where is this used? Oh, okay, it's used multiple times. I was going to say I could have just inlined this. And inlining is just kind of doing this instead. But since we use it twice, we don't want to process it twice. In fact, one optimization we could make here, and we may look at it in the future, is caching this value. Okay? So essentially what we're going to do, especially when there's a large amount of vertices, okay? Instead of doing this processing every time, we can have a list or dictionary. No, not a dictionary. Yes. No, we don't. No, not a dictionary. A list. And essentially we could say, if our list contains this vertex array, then just return it. And it would be a list of, no. It'd be a list of vertex array to float, a dictionary of vertex array to float array, where vertex array is the key to access the float array, yes. Okay. But basically, if our dictionary contains the key, this vertices, this one, then we're going to return the float array because we've already done the processing. Otherwise, we're going to do this and add it. This way, if you're kind of if you're trying to get a lot of different, or processing vertex a lot, then, or processing a lot of vertices, then you're not going to be, or it's going to be faster, essentially, because you're not going to have to process that much. Obviously, we're only doing this once because we're only calling it in the constructor. Okay? So, this is good. But one thing we do need to do is fix this draw method. So the first thing we're going to do is we're going to enable a new vertex attribute array. And if you guys remember from when we were doing rendering, a vertex attribute array is just an array that holds information. In fact, we use it to access the information in our shaders, much like a uniform. In addition, it is used in OpenGL uses it to also access the information, and we write things to it. So it's just a way to store data. Okay. Now there's also another thing that we're going to cover later called VAOs, which is a vertex attribute array. But it's a little different because it requires an object. We'll get into it later. Anyways, so now we just need to copy this, make this 0, 1, and that's all. And here's where all the magic happens. So the first thing we want to do is, what does this take in? It takes in an int index, that's 0, right here. And then it takes in a size. Well, what's our size? Our size is just going to be 2. Now you might be wondering, why is it 2? Why are you passing in 2? I mean, that doesn't make sense. But it does, because 2 is the amount of, essentially, values we're passing in. We're passing in our vertex position and our vertex texture coordinates. And that's actually not true. I was thinking of it in a global scale. My bad. Over here we're passing in 2 floats, x and y, and then over here, uvx and uvy. So then, over here, we're also going to pass in 2. Now, if it was a 3D vector, we would pass in 3, but obviously we're not doing that. So at this point, we're passing in a float, and over here false, you don't have to worry about this, it's just this normalized. Okay, I thought it was a stride, but this is the stride. The stride we do actually have to worry about. So the size is actually just going to be 4 times 4. Now you'd be wondering, why is it 4 times 4? Well, essentially what we're doing is 4 times 4 is essentially the same thing as writing size of float. And in fact, I'll leave it like this because the float may not always be 4 bytes. But typically a float is 4 bytes, which is why we were doing that. But I'm going to change it. So, size of float in here as well. So, the last thing we need to do is the fact this code is all the same. It's this that changes. These are offset, as you can see. Now, the offset is where you want to start accessing the memory in the memory block. And in this case, it's going to be after we read in the vertex position information, which is 2 floats. So the way our memory is laid out is we have 1 float for X position, 1 float, and then another float. So that's 4 bytes and another 4 bytes for the Y, and then another 4 bytes for the UVX, and then another 4 bytes for the UVY. So right here we have to do, our offset is going to be 2 multiplied by the size of the float. Now what you could do is you could even cache this. It's not a big operation to do size of though, so I'm not going to, but you could definitely cache it and optimize it even further. So the next thing we have to do, and it's the last thing in fact, is doing shading. Getting our shaders to work. Well, let me just open this in Visual Studio Code, and then we'll write the shaders together. So over here, we have it, and let's go into bin. In fact, yeah, no, I'm not going to do it in Visual Studio Code, I'll just do it in here. Okay, as I've been doing it for the other tutorials. Okay, so as you can see, we are already accessing vertex attribute array 1 in here, which is our layout location 1. Well, now what we want to do is access the second one as well. So layout location is equal to 1 in vec2 texture coordinate. Well, we're not going to be doing a lot of things in here. We're just going to be having an out. So if you guys remember, out passes it to the next shader in the line essentially. So obviously here, out actually just passes it back to the program. This is what OpenGL read as the color. That's why we have it named as out color. But that's not important. So out vec2. Now, since we can't have these two named the same thing, I'm just going to call this UV coordinates. Then UV coordinate is equal to texture coordinate. Right, that's it. So there's our vertex shader done. Now, fragment shader is also going to be quite simple. It just requires us to sample the texture. Now, this is where things get slightly more tricky, or if you want to say complicated, although I wouldn't necessarily classify it as complicated. The first thing let's do is just take in our UV coordinate. That's going to be important. So in vec2 UV coordinate, and then the next thing we want to do is have a sampler object. Well, in OpenGL, we have something called the sampler 2D, which essentially lets us sample a texture. But to do that, we need to make it a uniform. Now, we're not going to be passing it in anything though, and typically with uniforms you need to actually pass them in something or they're going to get mad, but with this, OpenGL already has something set up for us, a default value, so it's fine. Texture sampler, that's all we're going to name it. So we're going to have, let's just remove this for now. We're going to have a vec4 color is equal to texture 2D texture sampler and then UV coordinate.xy. And this is called swizzling, so we're essentially compacting it, and this is just returning a vector 2, or is it? I don't know if you could just pass in UV coordinate, but that's how I've always done it, so that's how I'm going to leave it. So you may be wondering, but where's the texture? How are we sampling our texture? We just have a texture sampler. Well, when we get into actually loading the textures, what happens is every frame, it is every frame, we need to bind our texture. So you need to say OpenGL.bind texture. In fact, we can look at this, right? In ending system, for example, I'll just show an example. GL.bind texture, and it takes in a texture target and then in texture. But we're gonna create that all. And the int obviously is the texture ID or the buffer object. So at this point, we may not have a texture bounds. So what we're gonna do is we have to check if the color is nothing. So if color is equal to vec4 0001, then out color is equal to vec4, and let's just make this let's just make it red. Yeah. Boom. Otherwise, so if we do have a color or texture color, out color is equal to color. And there you go. So the last thing we have to do, and this is what got me when I was writing the reference code for this, because when I was initially recording this video, it was like an hour long because I couldn't get something to work, so I recorded another reference, and it's kind of what I'm using now just to make sure I'm doing everything right, because there's some memory stuff we're doing, so it's just better if I, don't eyeball it, so to speak, or go wing it. I think that's the proper term for that. And now let me just pull up these reference vertices. I think it was in test game. I had it. There it is. So we're gonna set these up in a moment. But yes, one thing we have to make sure we're doing is in our rendering system, we have to enable textures. So enable cap texture 2D. If you do not do this, it's not going to work. I actually had this problem for quite a while until I realized, shit, that's what I'm doing wrong. So I fixed it now. So now we just have to set up some vertex texture coordinates, and these I just made up on the fly, and I have them up now. So it's just 0, 0, and these do work, by the way. Because I have a final product working. In fact, I could show that off right now. When we just get this done, I'll just pull it up and I'll show you guys what we're gonna be creating, or what we're gonna have done after this. So now you'll see that if we load up, we have red because we're not loading any, we're not loading any texture, so there's no, it just defaults to red. And later when we start working on materials and stuff, or sprite colors, I guess, we're gonna have it default to the sprite color, and we'll have even tints and stuff. So it's just gonna be so cool because we'll have everything working there. Anyways, this is it. This is the whole sprite rendering portion of it. Next time we're going to work on the sprite class. We're going to work on loading in the sprite. But before I go, I'll show you guys what it'll look like. So let me just get the reference open. And so this is how it's going to look next time. So you see I'm loading in a texture, and boom, I'm able to scale it, because I had that as a testing thing for some reason. But yes, you can see that we're going in now, and this is all perfectly able, And obviously I have another image, but I'd have to recompile. Anyways, guys, that's it. Thanks for watching, and I hope you enjoyed.